Good evening, everyone. My name is Noah Morejon, and I'm here to talk to you about balanced and unbalanced forces. So, what might be balanced or unbalanced forces? A balanced force is a force that acts upon an object to help it stay at rest, and is evenly distributed on all sides of the object. For example, equal force would be distributed on the sides, above, and even below it. And an unbalanced force would be, as I just did, interrupting its equality of force placed on each side and increasing the amount of force placed on a specific side, therefore moving it in the direction I'm applying the force into. So, some examples of balanced and unbalanced forces would be friction, inertia, gravity, and net force. So, first order of this is inertia. What might it be? Well, inertia is the force exerted by an object when any physical change is attempting to alter its velocity. An example of inertia would be this diamond. It is resting on the paper, and the paper is resting on the rims of the glass. Now, as you can see, it is balanced, somewhat balanced, and what I'm going to do is pull the paper towards my direction. On 1. 3, 2, 1. So, as I pulled the paper, the dime stood in place, which means that its inertia was so great that I was able to resist the moving force of the paper being pulled in my direction and dropped in the same position it was while on the paper. Which leads me onto my next subject, gravity. What you just saw there, when the dime fell, when I pulled the paper, was gravity acting upon the dime. Gravity is the force exerted by the Earth that pulls us towards its core. The force of Earth's gravitational pull is 9.8 meters per second squared. A couple more examples of gravity would be the Sharpie. If I were to get the Sharpie and use my muscles to throw it upwards, at a certain point it would stop moving upwards, and gravity would be so strong that it would begin to push it downwards towards the surface. Same goes for simply just dropping it. You do not need to throw it into the air for gravity to take place. And one example that you can also try could be just simply jumping. For example, if I jump and I reach that certain point, gravity is going to be pushing me down while I am jumping. While I'm jumping, I'm resisting the force of gravity. Therefore, when I reach a certain point, gravity pulls me down towards the center of Earth. So, next subject, net force. What is net force? Net force is the total amount of forces acting upon a singular object. So, as an example, I'm going to be using this inflatable elf box. So, while at rest, its net force will be 0. So when an unbalanced force, acts upon this box, whether it's pushing or pulling, its net force increases gradually. As said previously, it does not matter whether you push or pull it. And it does not matter what direction that you are pushing or pulling it in, whether it be diagonal, horizontal, or vertical. So, and last but not least, friction. What is friction? Friction is the resisting force that a surface exerts when acted upon by an object. So, for example, if you get both of your hands and you rub them together, you are now creating friction. Now, while you are creating this friction, you are also creating energy. And as you can feel, your hands are getting warmer. And this is due to all the energy that is being produced by all the friction you are creating by rubbing your two hands. This can also work if you simply get your hand or your finger and you simply rub a surface quickly enough to where it has the same reaction in which you create energy and that energy creates heat. Now, I'm going to review some of the things that I have just covered. Inertia is a force exerted by an object when a physical change is attempting to alter its velocity. Friction is the force exerted by a surface when an object comes in contact with it and slows it down. Net force is the total amount of force exerted upon an object. And last but not least, gravity is the force exerted by the Earth that pulls it towards its core. And this is something to remember as well. The force of Earth's gravitational pull is 9.8 meters per second squared. Now, I hope you all enjoyed this video, and I hope you all learned something, and I will see you guys next time. Until then.